Okay, in this video we're going to extend our conversation about imaginary, there goes my spell check again, imaginary numbers a little bit further to properties, to the properties that will hold true to imaginary numbers. So usually if we talk about addition and subtraction, this doesn't give many people any problems, because if you have two complex numbers, you add the real part and you add the imaginary part, imaginary values. So if we look at an example, 3 plus 2i plus 2 minus 4i. So all we have to do is combine similar terms. So notice in this circumstance, these parentheses don't really have much value because you have a positive between the two complex numbers. So we don't have to really worry about that. So all we have to do is combine our similar values. So we have 3 plus 2, that's our real part. So that's going to give us a value of 5. 2i minus 4i is going to give you a value of negative 2i. So the complex numbers added together still give you a complex number because we have a real portion and an imaginary portion. Be very careful, because if we start subtracting complex values, like in the example of negative 3i plus 6 minus 2i minus 10. So even though this doesn't fall in the same protocol of the a plus bi, that's okay. It doesn't matter if the imaginary portion comes first or the real portion. It doesn't make a difference. We can still combine similar terms. But be very careful, because this negative must be distributed to both the imaginary portion and to the real portion, because this is a distributive property that we cannot just ignore. So what this simplifies to is this simplifies into negative 3i plus 6, but then we're going to have minus 2i plus 10. So we actually have to distribute all of those values. And now we can combine similar terms. So we're going to have negative 3i minus 2i gives us negative 5i. 6 plus 10 gives you a value of 16. So in this circumstance, we can add and subtract, but making sure to watch out to distribute those negatives. So addition and subtraction of complex numbers doesn't tend to be very difficult or complex, no pun intended, but we have to be careful either way whenever we have that subtraction. So now let us talk about the multiplication of imaginary numbers. Imaginary numbers. So here we're getting a little bit more complex, but nothing we can't handle. We're going to talk about how to multiply. So let us talk about one of our radical rules. Our radical rules that we probably learned a couple semesters or classes ago. If you have the square root of a times the square root of b, your professor probably told you this equals to the square root of a times b, and they were correct. But this is only if a and b are greater than 0. This is only if a and b are greater than 0. A and b must be positive, because this does not hold true if a and b are less than 0. So let's say I give us an example. Let us say I give you an example. Let us say I say the square root of negative 2 times the square root of negative 5. To the untrained mathematician, scientist, they might say, oh, okay, I can apply my radical rule, and I can say this is the square root of positive 10. And you would be incorrect. You would be incorrect to say so, because this rule only works if your value of a and b are both positive. In this circumstance, we are going to have to get rid of that negative. We're going to have to get rid of that imaginary part. So I'm going to write this first value of square root of 2 as square root of negative 1 times square root of 2. And then over here, I'm going to write the square root of negative 5 times the square root of negative 1 times the square root of 5. So now I can go ahead and corral these. So I'm going to have square root of negative 1, which I'm going to call a value of I. square root of 2. I'm going to keep that square root of 2 there. And then I'm going to have multiplied by the other square root of negative 1, which is a value of I again. And then I have that square root of 5, which will remain over there. So now I times I know that's going to give me a value of I squared. And square root of 2 times square root of 5 gives me a value of square root of 10. And as long as we remember our little list that I is equal to the square root of negative 1, I squared is equal to negative 1, I cubed is equal to negative I, and I to the fourth is equal to positive 1, we can then write this as I squared, which is equal to negative 1, or negative square root of 10. So square root of negative 2 times square root of 5 does not equal to positive square root of 10. It equals to negative square root of 10. So be very careful when it comes to multiplication of your values. Be very careful about multiplying values, because the only time those will hold true is if those are positive. If those are positive. But if they're negative, they will not hold true. Let's go ahead and try another multiplication example. So let us go ahead and try an example of the square root of negative 49 times the square root of negative 100. The square root of negative 49 times the square root of negative 100. So we recognize that we cannot combine those, and we can't really take the square roots the way they stand, so we're going to have to simplify. So we're going to simplify the square root of 49 into the square root of negative 1 times the square root of 49. And then the square root of negative 100 into the square root of negative 1 times the square root of 100. And we recognize that square root of negative 1 gives you a value of I. The square root of 49 gives you a value of 7. The square root of this negative 1 gives you another value of I, and the square root of this 100 gives you a value of 10. So this will simplify into I times 7 times I times 10. And we know I times I gives me I squared, and 7 times 10 gives me a value of 70, but I squared is equal to a value of negative 1 times 70. So in fact, this is negative 70. So be very, very careful. Be very, very careful to take a couple extra steps to make sure you don't make a problem that's really easy and lose some big points. So you never want to lose big points on an easy problem. Let's go ahead and try multiplying two complex values together. So let's go try multiplying two complex values together. So let us say that I want to multiply 2 minus 3i times, let's say we want to multiply this times 1 plus 4i. So we're multiplying two complex numbers together. So this would help us to remember that FOIL method, the FOIL method of multiplying two binomials, where the F stands for firsts, the O stands for outers, the I stands for inners, and the L stands for lasts. So multiplying our first together, we'll do that in blue. So 2 times 1 gives me a value of 2. Now we're going to multiply our outers. 2 times 4i gives you a value of plus 8i. Now in light blue, we're going to multiply our inners. Negative 3i times positive 1 gives you a negative 3i. And then in orange, we're going to multiply our last, which is negative 3i times positive 4i, which gives you negative 12i squared. So we have a lot of colors right there, but I don't like drawing the arrows because I think that's a little messy. So I like to use a lot of colors. So again, we followed the first, the outer, the inner, last rule. So now we just have to combine our similar values. So we're going to combine our similar values. So I recognize I have a 2, and right now I have no other constant. 8i minus 3i gives you a value of positive 5i. And now we have to evaluate negative 12i squared. But remember, I squared equals to a value of negative 1. So we're going to have negative 12 times negative 1. And this gives me 2 plus 5i plus 12, because negative 12 times negative 1 gives you a value of positive 12. And now you can combine your constants and give you 5i plus 14, plus 14. So this actually gives you another one of those complex values. It's nothing too crazy, but you want to make sure to follow those properties whenever you multiply two binomials together. We have one more property we're going to cover, which I'll do in the next video, and that's going to be the division of complex numbers. But for right now, definitely take some time to practice multiplying out those complex numbers, and always remember this relationship of these complex values. So never ever forget these, because they will make your life much easier in the imaginary number system.